Okay, so we have started like melting point, we have studied like oxidation number and so many things, right? So today we will just move ahead of that. ठीक है, तो हम लोग अभी क्या पढ़ेंगे? The first thing that we are going to study is ionization enthalpy. ठीक है, ionization enthalpy. So what is that? How it works? आयनाइजेशन एंथैल्पी क्या होता है? मैक्सिमम कोई भी मेटल से अगर उसका इलेक्ट्रॉन्स को निकालना पड़े M+, तो जो एनर्जी दिया जाता है दैट इज आयोनाइजेशन एनर्जी. व्हेन यू राइट IE1 इसका मतलब होता है फर्स्ट आयोनाइजेशन एनर्जी. सो अगेन इफ यू पुट वन मोर IE2 it becomes M2+. ठीक है, so like that if you want to continue further, if you want to take out more electrons, IE3 it becomes M3+. generally जनरल जो ट्रेंड है, जनरल ट्रेंड में क्या होता है? योर फर्स्ट आयोनाइजेशन एनर्जी इज एक्चुअली lesser than the second ionization energy, is lesser than the third ionization energy, and so on. ঠিক আছে, তুমি মানে এটা এটমৰ পৰা নিউক্লিয়াস টু থাকিলে, shell to থাকিলে, if you want to remove the first electron, suppose there is 2 electrons, the energy that you will be giving, the energy that you will provide so that you lose the electron, okay, this is the first ionization enthalpy. After this electron goes out, the second electron now you want to remove after the first electron is gone, so that energy which will provide to remove the second electron is known as the second ionization enthalpy. Normally trend to okay, I1 less than IE2 less than IE3, okay, like that it will go on, but there are some exceptions, so let us study those exceptions. First of all, monotrachiba, okay, very important. First of all, always remember that few configurations are stable, okay, stable configurations of D block elements, of D block D subshells, okay. So stable configuration of D subshell are, the first is if it is D10, it is both stable. Why D10 is stable? Because it is completely filled configuration, completely filled configuration. ठीक है, তার মানে যদি D পাঁচটা সাবশেল থাকে, তো 1 2 3 4 5 পাঁচটা সাবশেল থাকে, এই পাঁচটা সাবশেলৰ ভিতৰত কেইটা ইলেক্ট্ৰন থাকিব? 10টা ইলেক্ট্ৰন সোমাই থাকিব, 6 7 8 9 10. So this is a very stable configuration, completely half filled, most stable, it is most stable হয়, ठीक है. Now if you move for the second, like which is the next very stable configuration, D5. D5 মানে okay, so yato pasta ase, so each orbital will have one electron each and will fill up all the shells, all the orbitals, this box, a box to naam ki orbital, a eta orbital bhitor eta electron thakibo, ठीक है. तो एक एक ऑर्बिटल के अंदर एक एक इलेक्ट्रॉन रहेगा. आर यू एबल टू सी द वीडियो properly? Means I am trying to rotate the screen but it is not happening, I'm not very aware of that. Is it okay?
Yes, sir.
Okay. So D, there is five electrons are there. 1, 2, 3, 4, 5. Each orbital has one electron. So this is also very stable. Not the most stable, but a little bit lesser than the most stable. Okay. Very stable. Why it is very stable? Karan to ki? Karan hol duta. Okay. There is two reasons why such kind of configuration is very stable. We have discussed. Number one, the first reason why it is very stable is equal repulsion, because all the shells have equal number of electrons, unpaired electrons, so they are very, so the repulsion is very similar or equal. Okay. Next is number two is high exchange energy. Already exchange energy ki hoy eblag ami discuss korilu. ठीक है? So we have till now discussed that two different types of configuration is very important and very stable, and that is D10 আৰু হল D5. কিবাকে যদি এটা এটমৰ D10 বা D5 configuration লোকে যাব পাৰে, then it will be very 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 stable. Okay. The other most stable configuration is D3. এটা তোমালোকে ভাবিবা স্যার D3 কেনেকে হল? D5 ঠিক আছে বুজি পালো, unpaired electrons পাঁচটা আছে equal হয়. D10 ঠিক আছে, কিন্তু D3 to কেনেকে? D3 भी होता है. D3 also is there. How come? Not for all elements, for coordination compounds elements, for those compounds, for those elements forming complexes. Complex মানে আমি coordination compounds পুরা complex এর উপরে পঢ়িলো, so এটো আৰু ডিসকাস নকৰো complex এটা মানে কি. So D পাঁচটা orbital থাকে ন, there is 5 boxes, 1 2 3 4 5. Now this D5 actually breaks down to, when the ligand approaches, they actually break down into T2G and EG. ঠিক আছে? এতিয়া T2G যদি electrons তিনটা থাকে মানে ইয়াতে এটা দুটা তিনটা, if 3 electrons exist in the lower, this is higher energy, EG2 whole higher energy, তার কারণে উপৰত আছে. Okay, so why the EG is above? Because it is having more energy, and T2G is having lower energy, that's why এটো তলত. আৰু যিমান কম এনার্জি থাকিব ইমান বস্তুটো স্টেবল হৈ থাকিব. ওকে, সো তুমি চোৱা, what is this configuration? D3, D3 means, D3 actually means T2G3 EG0. ठीक है? কেনেকে? Already T2G we have 1 2 3 electrons, and EG we do not have any electrons, so this is also a very stable configuration. So हे कारणे तीनटा configuration बहुत बेसी stable है, बहुत ज्यादा stable होता है, and that is D10, D5 and D3. All right, hopefully you can understand this part. If there is any confusion, you might tell me. All right, fine. So let us see some of the elements. Let us see. We have already known what are the elements in the first 3D series. 3D series or elements keta ki asile? These are scandium, science teacher, very cruel. Scandium, then manfeconizin. Manfeconi. Okay, so these are the first elements of the 3D series: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay, so if I suppose there are some elements jeneke tumar thakile suppose I write okay, I write chromium. Chromium or configuration to ki hobo? What will be the configuration of chromium? Chromium will be simply, because atomic number whole chromium are 21, 22, 23, 24, 24. So configuration to Ockerman special configuration, right? That is 4s1 3d5. Okay. So d5 configuration to retain korise. Okay. So chromium, if you give first ionization energy, it becomes Cr plus. Okay. So 3 Cr plus or configuration to ki thakbo? Eta electron herabo chromium e. Eta electron herabo means chromium plus what is the configuration? Argon 3d5. So naturally it is having a stable configuration, right? This is Cr plus d5. This is actually Cr 3d5. That's all right, but it is still having d5 only, so stability is not disturbed. Okay. Chromium or stability disturb hona tar karone first ionization energy of chromium is low. Okay, therefore IE1 for chromium is low, com. Okay, so like this, there is the case of first ionization energy, there is the case of second ionization energy. Let us discuss some of the other things also. Fine. Now let us discuss for second ionization energy. IE1 we have discussed. Acha, one more important thing. This is very new thing that happens. Special case. For example, only for vanadium it takes place. Okay. Vanadium has, it will a question as vanadium has low IE1 and have high IE2. Okay. Vanadium or ionization energy, first ionization energy to कम থাকে, কিন্তু second ionization energy to बहुत बेसी के থাকে. What is the reason behind that? The reason being, vanadium V is argon 4s2 3d3 because atomic number came on 23. Something special happens. Means what happens? 4s2 is there and 3d3 is there, right? 1, 2, 3, 4, 5. Okay. So it is having 4s2 3d3. So vanadium mein jete eta electron herai, like if it loses one electron, if it becomes V plus, that means it has lost one electron. V plus hoy pale, right? Atomic number remains the same, but it has lost one electron. So in such a case, ki hoy, it becomes 4s1 and 3d3, right? Because it will lose the electrons from the higher shell, not from 3d, but from 4s. So electron jete herabo, dutar pora eta hobo ultimate. But one more interesting thing will take place, that is energy alteration of 4s 3d. So this never happened before. Till now you have never got this thing. You are getting it for the first time. So ki hoy, see 4s1 3d mane 4s1 3d. Okay. So initially the electron was 2, now it has become 1 aru baki tinta thakile. Okay. Now what happens when vanadium is having plus charge, eta electron gusi gol aru eta electron thakile tomar 4s shell, this is the 4s shell, this is the 3d shell. So what happens, this one electron, he says that if I stay here, my stability is low, and if I can somehow transfer myself to this empty orbital of d, my stability increases. Okay, এতিয়া মানুহ সুধিব পাৰে স্যাৰ কেনেকে হল, because যদি এই ইলেক্ট্ৰনটো নিজক ট্ৰান্সফাৰ কৰিব পাৰে এইটো শেলত, Okay, if it can transfer itself into this empty shell of D, then the number of possible exchange increases. ठीक है, বৰ্তমান কি হৈ আছে চোৱা, এতিয়া আগতে 3টা ইলেক্ট্ৰন আছিল ন 3D, so 3D ইলেক্ট্ৰন কেইটা কি হ'ব, এক্সচেঞ্জ কৰিব. So what is the possible exchanges? Possible exchanges. What are the possible exchanges that can possibly happen? So it is given by number of unpaired electrons, that is 3, combination at a time 2 electrons exchange, so it will become 3 times of 2 times of 1. Actually likhe kene ke, I'll just write it once for you. It is equal to 3 factorial divided by 2 factorial into 3 minus 2 factorial. So it took you about 3 into 2 into 1, 2 into 1, aru 3 minus 2 kiman hobo, 1 factorial. 1 in mane ki factorial likhile mane ki hoy, you have to multiply that number with the numbers which is below that. Okay, janeke 3, so 3 2 1 4, 4 factorial is 4 into 3 into 2 into 1 teneke. Okay, so ekhini calculation korle kiman hola, we'll see that 2 and 2 gets cancelled. Okay, so ultimately ki thakile upor 3 thakibo, tolot 1 thakibo, correct? So ultimately the value of 3C2 ultimately becomes equal to, by doing the calculation, it becomes 3 only. But if you do 4C2 মানে ইলেক্ট্রনটো যদি নিজক ট্রান্সফার কৰি লয় 3D তেতে কি হ'ব, number of unpaired electrons in D subshell increases, so number of possible exchanges shall also increase. কি হ'ব, this will become 3C2 is equal to 3, so 4C2 ultimately 4C2 কি হ'ব, 4 factorial divided by 2 factorial, 4 minus 2 factorial. So it কি হ'ব, 4 into 3 into 2 into 1 divided by 2 into 1. 4 minus 2 কি হ'ব, 2 into 2, 4 minus 2 হ'ব 2 factorial. 2 factorial মানে 2 into 1, that's all. So it will be 2, 2 to the 4. So it is ultimately 6. So 4C2 কৰিলে তোমাৰ number of possible exchanges 6 ওলায়, আৰু যদি 3C2 কৰা তোমাৰ ultimately number of possible exchanges will become 3. So you see the number of possible exchanges increases by 2 times. ठीक है, so number of possible exchanges যদি বাঢ়ি যায় তেনেহলে energy which will be released during the exchange shall also increase. Okay, so eto jodi increase hoy jay ultimately, then the stability also increases. Okay, we have already discussed this fact before, that number of possible exchanges is directly proportional to stability. যিমান বেছি exchange হ'ব electrons, ইমান বস্তুটো stable হৈ থাকিব. Okay, number of possible exchanges is directly proportional to stability. Fine. So that's why in case of vanadium, what happens, the question is, এটা electron যোৱাৰ পিছত, because কি হয়, vanadium এটা electron দি দিলে কি হয়, ultimately it's earlier it was only 3 unpaired electrons, no, 3 unpaired হোৱাৰ কাৰণে number of possible exchanges, number of possible exchanges was 3C2, that is 3 only. But when the first electron, this 4s1 electron actually jumps here, after you remove 1 electron from S, then what happens, the number of unpaired electrons in 3D increases. As a result, the number of possible exchanges increases from 3 to 6. Okay, so as a result, what happens, therefore you understand that since the number of possible exchanges is increasing after the removal of the first electron, therefore the stability increases. Since the stability increases, the second ionization energy is going to be high for vanadium. Fine. So should I write it down? Okay, I'll just write it down. Okay, how to put in words this question? Vanadium has low IE1 but and have high IE2. So simply you will write since the number of possible exchanges increases, resulting into higher resulting into higher stability. Okay, since the number of possible exchanges increases resulting into higher stability, therefore vanadium has higher IE2 compared to IE1. That's all. Okay, so let us go for the second ionization enthalpy, IE2. Okay, some elements really have very high IE2, some elements have very low IE2. Let us discuss who has what. Okay, so যদি কাবাক তুমি suppose যদি এটা মেটেলক তুমি M2 plus বনাব বিচাৰিছা, then you must give some energy to it. মানে দুটা ইলেক্ট্ৰন যদি লুজ কৰি দিয়ে, if it is losing 2 electrons, if this metal is losing 2 electrons, that means the ionization energy given is equal to IE1 plus IE2, because IE1 দিলে প্রথম ইলেক্ট্রনটো ওলাব, the first electron will go out, and when you give IE2, the second electron will go out. Okay, so the total ionization energy is first ionization enthalpy plus second ionization enthalpy. ঠিক আছে, কেতিয়াবা IE1 is very normally কি হ'ব লাগে, normally IE1 should be lesser than IE2. This is the general trend. Okay, this is the general trend. It's a general trend হিসাবতে চলি থাকে. But sometimes what happens, IE2 might be lesser than IE1. That also is possible. We will see what happens. So let us see. For example, chromium or example to Akulo. Chromium is argon 4s1 3d5. Chromium plus is argon 4s1 4s0 3d5. Fine. Cr2 plus, you can see that it is argon 3d4. So ultimately to me, I said 3 different configurations are very stable, and these are d10 or d5 or d3. So by becoming Cr2 plus, মানে এইটোৰ পৰা যদি তুমি Cr plus বনাও বিচাৰা, then you have to give first ionization enthalpy. আকৌ Cr plus ৰ পৰা যদি তুমি Cr2 plus বনাব বিচাৰিছা, you have to give second ionization enthalpy. Fine. So দুটা electron বনি যোৱাৰ পিছত, what configuration is it getting? D4. Mind you, D5 was a very stable configuration compared to D4. Therefore, normally D4 হ'ব নিবিচাৰে. Okay, the element would again and again like to become D5, not D4. So since it does not want to become 3D4, the element is very upset right now with this configuration. Okay, it was happy when it was having 3d5. Now it is sad because it does not like this configuration. So what happens is your IE2, because it does not want to become like that, therefore IE2 is very high. If something is your favorite, you won't like to sell it, still somebody needs to buy it, then you will place its price very high. Okay? So ये है normal concept. So this is why IE2 is sometimes very high in some cases. Okay, all right. Similarly, copper also same condition. Similar condition for copper. Similar condition for copper. ठीक है? Copper's electronic configuration is very similar. Argon 4s1 3d10. So if you want to lose one electron, you must give IE1. It will become Cu plus. It becomes argon. Then what happens? It becomes 3d10. So 310 is very fine configuration. It's very happy right now. But okay. So copper plus, if it becomes, if you lose the electron, then copper plus may become Cu2 plus, which is again very, very unstable, 3d9. So it is not very happy in this configuration. Sorry, it is not very happy in this configuration. What is the reason behind that? Because it is losing a very stable configuration of D10. Okay, so generally IE2 is very, very high compared to IE1. So what you can write is the value of IE2 is very, very high compared to IE1. Abnormal increase of ionization energy 2 compared to IE1. Fine. Only on the basis of stable configuration, we can say something very similar. Okay. So there is a question. What is the question? Let us see. Okay. The question is, manganese has low IE1 and IE2, but high IE3. So manganese or first और second ionization energy to बहुत कम, किंतु third ionization energy to बहुत basic के होय. What is the reason behind that? Let us check. The answer is there in the configuration only. Manganese whole tomorrow, argon 4s2 3d5. Correct? 4s2 3d5. So to lose one electron, you have to give first ionization energy. It becomes Mn plus. Mn plus is configuration argon 4s1 3d5. Okay. And it is again losing energy. Again, if you give the second ionization energy, it becomes Mn2 plus argon 3d5. Cool. So ultimately, you are losing the electronic configuration. Oh, yes, it is becoming 3d5. Okay. So for the first ionization energy, you are not losing electron from the d5 configuration. Rather, you are losing electronic configuration of 4s. So 4s or 2 पर जो 1 जाए, no problem, no issues. At least 3d5 तो intact है, no? Again 3d5 now तो purely 3d5. It is more happy. Okay, if it was happy before, now it is happier, and in this case it is very, very happy. Okay, because it is having the complete configuration of completely half-filled configuration of 3d5. There is no extra baggage, there is no extra electron. But যদি তুমি এতিয়া manganese 2 plus 2 আকৌ যদি ionization energy এটা দিয়া, and if it becomes manganese 3 plus, এটো red zone হল. Okay, তাৰ মানে manganese 3 plus হলে কি হ'ব? Argon is 3d4. So So in such a state, what happens? Configuration is disturbed. 3d5 to gusi gol. 3d5 to gusi gol aru 3d4 ahi gol. So that is again unacceptable. Okay. So therefore, Mn3 plus generally form nohoy. Okay. Mn3 plus generally form nohoy. It is rare. Okay. So practically, keitaman electronic configuration to be nupua. Okay. Practically, zinc 3 plus not available. Not available. Okay, not available. You can see it is having D9 configuration. So D9 configuration thakar karone not available. Very much not available. Okay. So then cat is not available because it is ionization energy is very high. IE3 is super high. Fine. 3 plus diya ase no. 3 plus mane you have lost 3 electrons. So in order to remove electron, you need to give ionization energy. That's all. ठीक है? Okay, fine. So we do not get zinc 3 plus, we do not get cadmium 3 plus, we do not get copper 3 plus, nickel 3 plus. Okay, difficult to form. They are very difficult to create. Difficult to form. Okay. All right, fine. When in the charge of a metal increases, suppose a metal is simply a metal, it is electropositive. যদি কিবা একটা metal থাকে, it is generally electropositive. Electropositive to mane ki positive. Positive mane tendency to donate electrons. Okay. Tendency to donate electrons. M or pra jetia M plus hobo. Okay. So what will happen ultimately? Electronegativity increases. When it becomes M plus from M, electronegativity increases. It becomes M2 plus, electronegativity further increases. So as the electron density goes down, mane electron lose korar loge loge, charge to ahar loge loge, electronegativity khon bahi jay. Okay, fine, understandable. So this is one important fact, how electronegativity varies with charge. Electronegativity varies with charge. ठीक है? Metal se jodi electron lose kori ase, then it is known as oxidation, definitely. All right, fine. So oxidation number already ami kaile jo kaile discuss korilo. One second, let me take it out. Okay. So these are very stable configuration of the elements. So these are the oxidation state of elements. Different elements. We have seen what are the oxidation states, and these are some of the most stable oxidation states. Tumi chromium plus 3, chromium plus 6. Tumi sailwa, tumi, if you just figure it out, what is chromium plus 3? I'll just show you. Chromium plus 3. Okay. Chromium plus 3 is argon. See, chromium 2 ki asile? Chromium was 4s1 3d5, right? Chromium plus 3 is argon 3d3. So chromium plus 3 is very stable because of 3d3 configuration. I already go to either check d10 or d5 or d3. So if the configuration varies between d10, d5 and d3, then it should be very stable. Okay, so gotekhini oxidation state jiblak ami moi circle kori rakhisu red color wherever I have circled, these are very stable oxidation state. Already we have discussed yesterday. Okay, these are very, very stable state, stable oxidation state. Okay, so if somebody has not written, please write it down or take a screenshot, however it helps. Just take this part. Okay, very important. I'll tell you something very important right now.
Sir,
Huh.
sir, our physics class link is given.
It is started or what?
Yes, sir.
Okay, then I'll do one thing. I'll end the class, and if I get time today, I'll upload half an hour of more lecture today. Later
Okay.
on. Okay, fine.